Okay, today we are going to look at the law of cosines. We looked at the law of sines last class and it was solving for our oblique triangles. And so today we're going to solve for more oblique triangles. We're going to look at two different cases that we didn't look at last time using the law of sines. So our law of cosines, you're going to have to use the law of sines also. Now we're going to add to it the law of cosines. So the law of cosines says that if we have our triangle with angles A, B, and C, and then our side lengths are little a, b, and c, then we have the equals b squared plus c squared minus 2bc cosine A. B squared equals a squared plus c squared minus 2ac cosine B. So notice it's always the squareds we're multiplying and then our cosine of our angle and then we b squared. So depending on what side we need to solve for, we can do this. So in words, it's always going to be the same thing depending on your sides. It's the square of a side of a triangle is the sum of the square of the other two sides minus twice their product times the cosine of their included angle. So these are three formulas that you will need to know. Again, they're very similar. It just depends on what side that you're looking to solve for. Sorry if you hear bells or something in the background. My dogs are wanting to go outside, so hopefully they won't bark at you. So looking at this, we have four cases that I kind of showed you last time, and we looked at the first two. So now we're going to look at the last three. So this one is if you are given a side angle side of a triangle, and then we need to solve to find everything else. So if we're given this, we're going to use the law of cosines to find the side opposite the given angle. Then we're going to use the law of sines to find the shorter side. Notice it's the opposite of the shorter side. When we find this, it will always be an acute angle. And then we're going to find the third angle by just subtracting 180 minus the two angles that we know. So looking at an example right here, we want to solve the triangle shown. I know yours isn't shown. You'll have to draw it on your notes, but you can draw in your triangle. So here we know, I have my A, B, C, so we can fill out what we know. We know B is 20, C is 30, and A is 60. So going through the steps that I just gave you previously on there, side opposite the given angle. Well, the given angle is A, so we're going to find little a. So our formula, we're going to use the a squared one. So we know BC, we know all this information, we just need to substitute it in. So a squared equals 20 squared plus 30 squared minus 2 times 20 times 30 cosine of 60. And now it becomes, again, a lot of calculator problems. So plugging that into our calculator, you would get a squared equals 700. This works out nicely. Because it's a squared, now we have to square root this to get a by itself. So if I square root this, I get a is approximately 26.46. Okay, so now we know what our angle A is. Okay, 2646, there it is. So there's our little a. So now we know A, B, C. We need to find step 2, example 1 here. So what we're going to do next is solve the triangle shown with a equals 60, our same thing, we just found our 2646. 2 is to use our law of sines to find the angle opposite the shorter of the two given sides. So you have to look, the shorter of the two given sides is 20. We got one is 20 and one is 30, so our shorter one is 20. So that means we're going to find angle B using the law of sines. So remember our law of sines? B over sine B equals A over sine A because A is what I know both of. Plugging those in, 20 over sine B equals square root of 700 over sine 60. If you plugged in 26.46, that's going to be fine. You might change by a few little decimal places, but not enough that will make a difference. So now if I have my over sine of 60, we want to solve for B. Whoops. So remember when we do this, this is sine B equals square root 700. Whoops, just kidding. Did that backwards. Let me erase that real quick. Maybe erase that real quick. Erase. Okay, sine of B is going to equal 20 sine of 60 divided by the square root of 700. And remember, because I need B, it's an angle, that's when we do our inverse sine. So B is going to equal the inverse sine of 20 over sine of 60 all over the square root of 700. So plug that into your calculator so that you can look and see what your angle is going to be right there. For our B, I got 40.89. So I know up here that B now is 40.89 degrees. It's not written very nicely. And then to get C then, we're just going to do 180 minus 60 minus 40.89. So our angle C would be 79.11 degrees. So that would give us all of our answers on there. Okay, look at another one. This time, if I want to solve a side, 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 so this time you're given 3 sides. Use a law of cosines to find the angle opposite the longest sides. The first thing you want to find is the angle opposite the longest side. Then we'll use a law of sines to find either of the 2 remaining angles, so it doesn't matter which one we do. And then find the third angle again by subtracting 1 and 2 from 180. So looking at example 2 on here, we want to solve the triangle ABC. I'm going to know that A is 6, B is 9, C is 4. So we know all the information right here. So step 1 was to use the law of cosines to find the angle opposite the longest side. Okay, well, what was our longest side? Our longest side is 9, right? So that means I'm going to use B because that's what we have. So B squared. Substitute in what we know. This time what I don't know is going to be capital B. So we substitute in our 9 squared and our A, 6 squared plus 4 squared minus 4 times cosine B. And we need to solve this for cosine B. So we want to get cosine B by itself. So that means you need to take your 9 squared. We need to subtract 6 squared, subtract 4 squared from both these over here. Oops, not sure why I did that. Minus 4 squared. Okay, so if we do that, oops, cosine B equals negative. If we work through all of this, okay, so you're going to have 9 squared minus 6 squared minus 4 squared. That gets rid of these 2. Divide that by negative 2 times 6 times 4. That's going to be my cosine of B. Okay, so if we work all of that out, you can figure this out. This means that cosine B is going to equal negative 29 over 48. And then remember, you have to do the inverse. So B is going to be the inverse cosine of negative 29 over 48 in our calculator. So if you plug that into your calculator, where's my answer here? What did I get? I got B is 127.17 degrees. Okay, makes sense. Up here it's going to be a bigger angle. So now I know my B. So once you know your B, part 2 on here is to use the law of sines to find either of our 2. I put in my B that I knew up here. So we're going to use our law of sines right here. I'm just going to solve for A first. It doesn't matter which one you actually solve for first. So that means I'm equals 9 over sine of 127.17. So if we work this out, remember sine of A is going to be 6 sine 127.17 over 9, because I need of all of that. 6 sine 127.17 over 9. So when I put all that in my calculator, I got A to be 32.09 degrees. Once you know that, so I know that my A up here is 32.09, I can now find C, because I can just do 180 minus 127.17 minus 32.09. So that means angle C is 20.74 degrees. That gives us all of our triangles. Okay, let's look at another example, example 3. So it's given me a side, and an angle. So when it's given me a side, and an angle, that's when we first use the law of cosines to get the missing side. So I know AB, I know my A is 10, I know my B is 3, and I know my C is 15. So to find my missing side, I want to solve for c right here. So I'm going to use c squared here, my law of cosines. So we're just going to plug in our a cosine of c, plug in all of our information. So now take a moment, put this in your calculator. When I put this in my calculator, I got c is approximately 7.14. So that gave me my little c right there. So now I know that c is, put everything up here, 7.14. So now step 2 is use law of sines to get the smaller angle. The smaller sines with my b's and my c's. Whoops. Thought I had that on there. I guess I don't. Okay, so this is going to be 3 over sine b equals 7.14 over sine of 15. So sine b equals 3 sine of 15 over 7.14. Again, I need an angle, so that means I need the inverse. So inverse sine 3 sine 15 over 7.14. So take a moment, make sure you can get these in your calculator, plug this into your calculator, and I got 6.24 degrees. So now I know my b up here is 6.24. And then to solve for c, we just do 180 minus 15 minus 6.24. And that would give us 158.76 degrees. So there's our example 3. So those are just some simple ones where they're asking you to solve a triangle given information. Now we need to look at some applications. There's lots of applications that deal with law of cosine and law of sines. We've looked at some for law of sines. So let's do law of cosines. Here we have a helicopter travels 165 miles from point A in the direction of 130 degrees and then travels in the direction 245 degrees for 80. How far is the helicopter from A? So we're going to start at point A. Okay, we're going to travel 165 miles, 130 degrees. So think about this as our 0, 0 in a unit circle. So 130 degrees is over here. This right here would be 130. Okay, and I'm traveling 165 miles. So then from that point right there at the end where I stopped, I'm going to go 245 degrees for 80 miles. So again, think about this. We need to go think about that as being your 0, 0 point right here. 245, so from here to here is 245 degrees. And then we're going 80 miles that direction. So then we need to complete our triangle right here. So things put in, where's my, I know E. I'm going to say that C is 165, so label my B and C. So now we need to find some information. So what we need to find, we need side, angle, side. So I need to find angle B right here. What we really want is this right here, little b. So to do that, I need my angle B. So we're going to have to use some things that we know about angles to figure out what angle B is right here. Okay, so let's think about this for a moment. That this is a 90-degree angle right here. So we know all the way from the beginning right here to this angle right here is 275, right? Okay, so what is going to be this little angle right here? If we figure that out, let's see. Actually, let's start down here first. This is 130. This is 90 of it, so I know this little angle right here is 40. And then by knowing alternate interior angles, things that you learned last year, that also tells me that this is 40. Okay, so then we also know that this is a 90-degree angle. We can figure out this angle right here as 65 because you could do 245 minus 180. So then if this has to be 90, that means this angle here is 25 degrees. So this whole angle together is the 25 plus the 40, so our angle B is 65 degrees. Okay, if you need it out on a little bit bigger picture, and hopefully that would help you. Again, we're looking for b, so we're going to use our law of cosines, and we're going to use our b squared one right here. We're going to plug in what we know. So we know our a, we know our c, we know all of our angles. So we're going to plug this all into our calculator. Again, take a moment, plug it all in, figure out what we're going to get. You should get 149.89. Okay, it only asks for how far the helicopter is from A, so that's all I care about. I don't have to find any of the other information. I did have to find some angles to get to that point, but I don't have to find anything else. Okay, how about example 5 on here? So example 5, we want to find the lengths of the diagonals of a parallelogram with sides 30 and 70, and one angle is 65. Well, let's think about it. We have a parallelogram over here. We draw a diagonal. I know one side, I know the angle is 65. I know one side is 70 and one side is 30. So we want to find that red diagonal when we do this. So things we know, I labeled mine with my A, B, and C. If you label them different, it doesn't make them wrong. It just means that they'll be different when you fill in a box like this. So I let A be 70, B I don't know, C is 30, and then my other angle. So what I need is this right here, little b. So that means I'm going to use my b squared, plug in our A, our C, and our angle B. Take a moment again to solve for your b, and you should get 63.44, plugging it into your calculator. Okay, so now it says to find the lengths of the diagonals. So I found one diagonal. Now I need to find this other diagonal that would be going this way. Okay, so we just found one. So now what we would be finding is this diagonal. So this time my angle is 115 opposite that side. I still have my sides of 70 and 30. So we still have our side angle side. I have my labels again. And then we need to solve for little c this time. So again, you're just plugging in. It's a lot of plugging into the formulas, picking the right formula, subbing it in, and being able to use your calculator. So I plug it in. Again, make sure you can get these answers in your calculator. You're going to have to do this again. So make sure that you can work these and go through and do them all. Don't just take my number, write it down, and then you don't know how I got it. So this diagonal is approximately 87.03 inches. Okay, a couple more. If we look at example 6, I have 2 airplanes leave an airport at the same time on different runways. One flies at a bearing of north 66 degrees west at 325 miles per hour. The other airplane flies at a bearing of south 26 degrees west at 300 miles per hour. How far will the airport be after 2 hours? 2 hours is important because where are we getting our information? So you have a little chart on here. Well, where are my 650 and 600 coming from? That's because I'm 25 miles per hour, but if I'm traveling 2 hours, that means I'm traveling 625 or 650. Again, 300 miles per hour for 2 hours would be 600. So that's where that A and C of 650 and 600 are coming from. Notice I put the picture on there, so I'm giving you your angles. You know your angle right here is 66. We know this angle right here is 26. So because I want side B right here, that means I need to figure out what this angle is in the middle. Well, if I make this straight line, everything on a straight line has to equal 180. So if I know one's 66 and one's 26, then to find my next angle, I just subtract it. So angle B is going to be 88 in here. This is 88 degrees. Okay, so now we have A, C, and capital B, and we want to find our little b. This is just putting everything in a chart again, if that helps you. Okay, filling in what we know. We want to solve for this little b right here. So in my law of cosines, I do my b, substitute in A, C, and capital B. Plug it in. Excuse me. Again, use your calculator to solve. You should get b is approximately 869.07 miles. So it asks us how far the airplane would be after 2 hours. If you just gave me this answer, that would be fine. A lot of you like to write this, so in approximately 2 hours, in 2 hours it would go approximately 869 miles, so 0.07 is barely any. One last example. Here we have a triangular plot of land has sides 420 feet, 350 feet, and 180 feet. So it's giving me, so when we look at our side on here, just put if you draw a triangle, label it with your A, B, and C. Again, if you labeled it different, it wouldn't be counted wrong, but you have it on there. So then we look at this. Sorry, my computer went to sleep on me. Okay, so now when I look through this, what do we want to find? A triangle plot. We want to find the smallest angle between the sides. Well, which one is going to be the smallest angle? It's going to be the angle with the smallest side. So the smallest angle is going to be B right here. So that means I need my B squared. Pick the right one. We know A, we know C, and we know little b. This big B would be our unknown. So we plug in what we know. Plug in what we know, and then if you want to approximate, you can, or you could just, work it all out, because our cosine B would be 180 squared minus 350 minus 420 squared, 420 squared, and divide by -2 times 350 times 420. Okay, that would get you a value, and you can approximate. You want to keep as many decimal points as possible if you approximate it, or just remember you need the inverse of what all of that is. So you would need the inverse of 180 squared minus 350 squared minus 420 divided by -2 times 350 times 420. You just don't want to do a bunch of rounding. If you do a bunch of rounding, you'll end up with the wrong answer. So this would give me B equals, if we plug this into our calculator, approximately 24.98 degrees. Okay, again, if you just would round this inside answer to like 1 or 2 decimal places, you're not going to get this angle and it would be counted wrong. You have to keep some decimal places. Okay, so you're going to have, again, a worksheet for your homework. If you have questions, please come see me before or after school seminar, so that you are staying caught up on what is happening. So have a great day. Again, let me know if you have any questions.